Good day, everyone, and welcome to today's training session. This is to officially welcome each and every one of you to this very interesting session of our course on solar power system installations. This is to welcome you all. The course started uh, on our WhatsApp platform, and we have been able to introduce what solar system is, and in that introduction we made sure to inform you, to tell you guys that this solar energy is gotten through the sun when one of the solar components absorbs the rays of the sun and then convert it to electrical energy for you. We went ahead to tell you that there are two types of solar power system setup. You have one, the on-grid type of solar power system, and two, the off-grid type of solar power system. And then we broke it down for you guys for better understanding. The on-grid type of solar power system is a type of solar power system that gives you 24 hours electricity. It gives you access to clean energy, to good energy, availability of energy at all time. That is what that on-grid solar type of solar power system does for you. How does it do this? It does it through the act, or due to the fact that you have access to more than one power supply source. What that simply means is that your on-grid type of solar, your power supply installation enables you not just to be on your solar, but also be on any other type of available power supply source. Which means when you run an on-grid type of solar power system setup, you can be on your solar, which is through your solar panels. You can be on your grid, which is national grid you have in your various countries. You can also be on generator or any other type of energy supply source that is available in that your facility at that point in time. That is what it simply means. So, moving ahead, we also talked about the off-grid. The off-grid only gives you or enables you to be on one type of solar power supply source, which is what, which is the solar panels, okay, and its various installation components. All right, we introduced the various types of solar components used. We said there are four basic types of solar components. One, your solar inverter. Two, your solar charge controller. Three, your solar batteries. Four, your solar panels. These are basically the four basic types of solar components used for any type of installation. However, we didn't just stop them. We went ahead to tell you guys that there are other components which are used for basically, strictly for safety and protection of your solar system. Alright, as we wrapped up the last session previously, there were questions that came up, and such questions were like, how do you size, how do you know the number of solar panels, how do you know the number of batteries, how do you even know the size of solar inverter suitable to power up your facility. But then we went ahead to tell you guys that it is not about knowing the size of inverter or how many solar panels that you are required. Okay, first thing first, you need to have a basic idea of the energy need of that your requirement, and that is what we are here to deal with today. So today, from this very moment till the end of the training course, we are going to be talking about what we call energy audit. Alright, we are going to be talking about energy audit. And as we always have it, energy audit is subdivided into two. On one hand, it tells you about your energy need, and on the other hand, it tells you to size your various solar components. Okay, So, like I said earlier, please, if you are here and you are in a noisy place, kindly mute yourself, alright, so that you don't disrupt the activities of the class. Okay. Alright, testing the microphone. I hope you all can hear me clearly. Mr. Steven, can you hear me clearly? Your mic is off. You can give me a nod. Just nod with your head. I can see you clearly. Alright, thank you. So who else can hear me? Can any other person hear me? Let me know you can hear me. Raise a hand. Give me an emoji. I want to know you can hear me. Alright, Mr. Anyway can hear me. Who else? Mr. Matthew can hear me. How about Mr. Taiwo? Can you hear me? Mr. Daddy can hear me also. Alright, thank you. Thank you so much. So, alright, the next thing, I hope you can see my screen. Can see what I'm displaying on my screen. Mr. Steven, can you see what I'm displaying on my screen? Just give me a nod, sir. Alright, thank you so much. Thank you. Alright, so this is the course, energy audit. This is the topic, energy audit. And from my screen, you can see it is the determination of the energy requirement for a building. Now, in my earlier introduction, what I said was that any energy audit is divided into two. On one hand, it helps you to know your energy need, and on the other hand, it helps you to size your various solar components. How does it do these things? Firstly, it is the determination of your energy requirement for a building. That is what I mean by the energy need of that facility. Energy audit helps you to actually know how much energy are you consuming, how much energy is that your facility consuming, how much energy is are your various appliances going to be consuming when they are powered up using either the solar system or any available source of power supply in that facility. That is one. Two, it then uses the information of the energy need, which means that after you must have known the energy consumption of that your facility, which is in watts, you then use it to size your various solar components. On my screen, you can see it is said that it is a careful examination of the electrical loads, which means before you can get the energy need for a facility, you have to have information of the various appliances that are available in that your facility, and then you will perform a little magic on them to know the energy that they are consuming. It is crucial for standalone systems, which are commonly seen in Africa and some parts of the world. Okay, so this is energy audit. It helps you to know your energy requirement for your facility. What quantity of appliances are available in that facility. So, energy audit helps you prevent oversizing of the system, safeguarding your electrical appliances from damaging from inappropriate power surge, and it generally saves you cost. Now, this next slide is telling you basic things that the energy audit does for you. On my screen, you can see that energy audit does basically three things for you. One, it helps you to prevent oversizing of your system. Two, it acts in terms of safety. And three, it also generally saves you cost. Now, let us connect the item 1 to item 3, and then we can leave the middle item for a later discussion. Now, the item 1 I'm talking about here is the energy audit prevents you from oversizing of your solar system and the generally saving you cost. Most of us here are professionals when it comes to electrical installation. Most of us here are technicians. Most of us here are craftsmen. Most of us here are professionals in electricity. Alright? But then when it comes to solar system installation, there is a little bit of trick in it. So it is not so straightforward that anybody can actually venture into it. The truth is that anybody can actually venture into it. Yes, any novice can actually venture it, but you must dedicate your time. You must give it your time. You must give it your interest. You must do research on your own. You must learn new things before you can become a professional in this field. Now, how does energy audit prevent oversizing of your system? Just like we have said it. Mr. Timothy, you have unmuted yourself again. What is happening? So, let's take for instance, let's say Mr. Steven is our client for tonight. Let's say Mr. Steven has invited us to run a solar system for him. And due to the fact that we do not know the work, but then we are electrical personnel, and Mr. Steven has seen our works when it comes to electrical installation, and he has asked us, can you do solar? We said yes. Mr. Steven has now invited us to power up his facility, and we just go ahead and recommend any size of system: 10 kVA, 10 solar panels, 8 batteries, and then you see 80 amps charge controller. At the end of the day, we didn't look at what we had to power up. Then, on the long run, another installer comes in, a solar professional comes in, and Mr. Steven has spoken to that professional and said, oh, he has a new system set up, he's enjoying it, this and that. That professional will ask the basic question, what are you powering up? Mr. Steven will then say, oh, he just powered up his laptop and his mobile phone. And the professional will say, and you are using a 10 kVA system to just run that small quantity of load. Now, that alone has done a lot of damage to the installers who did that project. Why? Because they did not do due diligence in sizing that facility. Alright, so which means for you to power up just a laptop and a mobile phone, you do not need a 10 kVA, because a laptop does not consume as high as 200 watts or more than 200 watts, and your phone is about 10 watts maximum or even 15 watts, depending on the type of charger you are using to charge your phone. So you see, it is not even up to 1 kVA. So 1 kVA is okay. In that instance, you have oversized that your solar system. 1, 2. You have also overestimated the cost of installing that system. Remember, the cost of installing a 1 kVA system is not the same with the cost of installing a 10 kVA inverter system. So that is the theory behind helping you to prevent oversizing and then generally saving you cost. In summary, solar energy audit links the energy need of the facility to the sizing of the various solar components required for the system setup. I hope we are together. I hope we are still together. Mr. Steven, are you there? Alright, Mr. Matthew, I can see your hand up. Alright, so there are things to consider during solar energy audit. There are things to consider during solar energy audit, as you can see on my screen. 4 parameters are to be taken into consideration. 4 parameters to be taken into consideration as it concerns your solar energy audit. 1, the list of electrical appliances to be powered by the solar system. 2, power rating of the electrical appliances in watts. 3, daily running hours of the appliances. And 4, total energy consumption of the building. Now, these things to consider, or these 4 parameters, are the essential parameters which you would be needing, which you will be using in order for you to size up a facility, in order for you to know the energy being consumed in a facility. Without these 4 parameters, you would not be able to carry out your duties as a professional in the field, because these are basically the things, the information you need from the client in order for you to work on his or her facility. All right. So, importance of solar energy audit: provides data needed for the appropriate system design, identifies opportunities to reduce energy use, helps you to reduce the capital cost, and also help you to ascertain the backup time for the solar storage. So these are just a few of them. And if you have a copy of the training manual, that's the PDF, you can look into it. There are other importance, advantages and disadvantages of energy audit. All right. There are other things, important information as it concerns energy audit, that you can have access to when you have the training manual. Now, this is where we would wrap it up. Okay. Safety. This is where we'll wrap it up. Safety. Remember, previously when we were talking about the energy audit, we said that energy audit does basically 3 things for you, even though it does other things for you, but most important things it does for you are 3. 1, helps you prevent oversizing of your system. 2, it gives you appropriate safety, and 3, generally saves you cost. We have talked about oversizing of the system and then saving you cost. Now it is time for us to talk about the safety aspect of it. Mr. Anyway, please kindly mute yourself. There's a noise coming from your end. Please kindly mute yourself. Thank you. So safety, as it concerns solar system, is keeping the entire solar system safe. Not just the solar system, plus your home appliances. Yes, you must safeguard not just your solar system, but also your home appliances. You must safeguard not just your solar system, you would also be needing to safeguard your home appliances. A safe solar system is free. This is very simple. I don't know why some of you cannot just obey this. It's very simple. Mr. Anyway, your mic is open. I have told you severally, mute yourself. Don't force us to remove from the platform. You are busy doing another thing over there. We don't want to disturb your own activities, and we don't want you to disturb our own activities over here. Okay, let us cohabit safely here. Okay, thank you. So, a safe solar system is free from both human and natural disasters or hazards such as fire outbreak, overloading, overvoltage, undervoltage, lightning effect, and shock. Now, when we talk about safety, it is very important. Okay, it is very, very important. You have to take safety to be as important as even safeguarding your own life. Yes, your solar power system has 2 parts. It has the AC part, it has the DC part. When we talk about safety, you are also going to safeguard the solar system, the AC part and the DC part. Alright? Now, in safeguarding both the AC part and the DC part, we are not talking about you preventing certain things. We are talking about safeguarding in terms of earthing, in terms of grounding, in terms of your surge, in terms of using your breakers, your fuse. There are so many safety tools and gadgets which can be used. Yes, so many safety tools and gadgets which can be used. However, you might have idea of these safety tools and gadgets, but then do you know how to apply them? Mr. Anyway, this is the last warning for you. This is the last warning for you. Once that noise comes up again, we will remove from the platform. We won't care if you have paid or not. We will remove from the platform. Please obey the rule of the platform. Mute yourself. I don't know why you keep on muting. What is the problem? You have muted yourself before, but you keep on muting. What is the issue? Alright, so back to our studies. On my screen, you can see the basic safety tools and gadgets. You can see the basic safety tools and gadgets. You can see your breakers, your fuse, your surge, your AVR, your voltage monitors, and whatever you may have. Even your changeovers, your automatic changeovers are also here and available. Your automatic changeovers are also here. So these are the basic tools you will be needing. Like I also talked about, earthing and grounding, they are also very important when it comes to your solar power system. Alright? But then, do you know how best to earth your solar system? Do you even know the part of your solar system you are expected to earth? All these safety tools and gadgets on the screen, they are both AC and DC. Do you know what part of your solar system you are allowed to use each of them? On my screen, you can see for the breakers, you have the ones we call the MCB and you have the other one we call the MCCP. Do you know how to identify them? Do you even know how to use them? That is what you get to learn when you enroll fully for the course. Alright? When you enroll fully for the course, that is what we expose you to. We would then teach you how to make use of these things and where to apply them. So this is your safety box. This is your safety box for those of us who are just coming into this field. This is your safety box where you would have all your safety tools and gadgets, all the breakers, all the fuse, all the surge. So this is where you have it. Your breakers and your fuse and your surge, they are all for protection. What are they protecting against? Those are the questions you would ask us and we would answer as our fully enrolled students. Alright, so the first phase of the training has been completed for tonight. Yes, we know we have given out so many information, so much information that you guys might have certain questions to ask. Now, just as we had it on WhatsApp platform, for this very class again, we will give you guys the opportunity to ask your questions, alright? This is the way it goes. Once it is time to ask, you tell us your name and your location. You are telling us your location due to networking we are trying to create, okay? We want to know where you are from. We want to do business with you. We want you to also get to do business with us. So that's why we need your to know your location. Alright. Okay, so let's have the first phase of questions right now. If you have any question or questions, let's hear from you, please. You can unmute yourself, please. Let it be from a quiet background. If you're in a noisy area, please use the chat box to send in your messages as text, please. Don't unmute yourself if you are in a noisy place. Thank you. I could see some hands up previously. That's Mr. Zamali Kasonde. Are you raising up your hand to ask a question? Kindly unmute yourself now, please. Oh, can you all hear me? All right, Mr. Steven, you're always active. Okay. All right, Mr. Timothy can hear me. Who else can hear me? Mr. Matthew can hear me. Okay. Mr. Gift can hear me. Mr. Hyacinta can hear me. Mercy, can you hear me? Are you a
Yes.
Okay, Mercy, you are a mister. Okay, I was about to say madam. Sorry for that. You're a mister. All right. Okay, so then we have to go ahead. So there are no questions. We have to go ahead. So for tonight, we'll be focusing on another topic called electrical load analysis. We'll be talking about what we call electrical load analysis. What is electrical load analysis? Electrical load analysis is a calculation or series of calculations which tells you your energy need. As you can see on my screen, electrical load analysis is the calculation, series of calculation or the process of evaluating the energy needs of a facility. When we say energy audit helps you to know the energy need of your facility. In order for you to know the energy need of your facility, you need to go through what we call electrical load analysis. Electrical load analysis is that which gives you the information of what you are powering up, at what time you are powering it up, the size of what you are powering it up, and the backup time for that facility. That is what you will be needing. Those are the information you'll be using in order for you to get your energy need. So, if for you to say a facility is consuming 5,000 watts, it means that you have evaluated that the loads in that facility. You have done major calculations and system design before you can arrive at that your system at your facility consuming 5,000 watts. All right, so electrical analysis is what we are going to be looking into. Now, let us take analogy of what electrical load analysis is. Let's say again, Mr. Steven, who is our client for tonight, let's say he has invited us to run a solar system in his facility. On getting to that facility, there are three basic questions to ask Mr. Steven. Okay, three basic questions to ask Mr. Steven. One, we would ask Mr. Steven to know his energy need. So we will ask Mr. Steven what is his energy need. Alright, or what is the energy need of the facility. If Mr. Steven is new to this field of solar system, he might not understand what we mean. So we will break it down for him by asking him to give us a list of the various appliances he intends to power up using the solar system. At that point in time, Mr. Steven can now say he wants to power up his fan, his refrigerator, his air conditioner, his water pump, anything. You know, there is this funny question that we always get sometimes. Can your solar system power up freezers? Can it power up AC? Or can it power up your water pump? Your solar system can actually power up anything for you. Yes, it can actually power up any appliance for you. However, that your solar system must be designed the right way before it can power those things. Yes. So if we have asked Mr. Steven his energy need, and he has given us a list of what he intends to power up using the solar system. Mr. Abbas Kamara, please kindly mute yourself. There's a noise coming from your end. Please kindly mute yourself.
Okay, sir. Okay, no problem. We is a quiet place, sir. Place is very quiet. The
Mr.
place where I am now, it is very quiet, sir.
Still mute yourself. We don't want to know whether it is quiet or not. Mute yourself. I said there's a noise coming from your end. Mute
Do
yourself,
you
sir.
get
It's
me
very
now?
easy. You might be connected to an external speaker. Mute yourself. Is bringing an echo here. It's disturbing others. It's very simple. Ah, God. Alright, so sorry for that. Now we have asked the first question, his energy need. He has given us those things he wants to power up, the fan, the freezer, the laptop, whatever. Then we will ask the second important question. What is this second important question? This important question is the budget. Sorry, backup time. Alright, so we would ask our client, Mr. Steven, what is his backup time for this solar system he intends to install. Now, asking Mr. Steven the backup time for the solar system would help us to know how long he wants that solar system to run. Now, remember, let's take ourselves back. Let's take ourselves back to when we introduced the battery system. We said that one of the basic reasons that made us to include the battery system in the solar system setup is for the act of backup. I don't know why can't some people just obey simple rule? What is the problem? We need to set an example right now because we can't continue like this, honestly. If we don't make example of somebody, some of you would never want to obey the simple rule. Mute yourself. If you are not disturbing, I wouldn't say you are disturbing. What is all this? Ah, So, the backup time tells you how long the energy stored in your battery system would run. And like I was saying, one of the reasons why the battery system was included in the solar system setup was for the act of backup. We know that the source of energy supply for solar is through the sun when the solar panels absorb the rays of the sun. Okay. However, we also know that the sun does not stay up all day, but then you might need electricity in your facility at specific times. How do you get to use this electricity when there is no sun? That is how the battery came to be, which simply tells you that when the sun is up, you design your solar system in such a way that your solar panels produce a lot of energy for you to use in your facility and then store up some in your battery bank. That your battery is like a container or a tank, which helps you to save this your energy for later use. So when there is no longer sun, you can now fall back on that energy stored in your battery. Therefore, when we talk about the backup time of your solar system, we are technically trying to know how long will the energy stored in your battery system last for you. So Mr. Steven can then tell us he wants his backup to be 4 hours, 5 hours, 12 hours, or even 24 hours. We will just smile. Why are we smiling when he says 24 hours? Because we know the higher his backup time, the higher the cost of installing that system. That is very simple. Okay, that is very, very simple. So we would get information of the energy need. We will also get information of the backup time. Now, the last question there, which we refer to as the bonus question, is a question we call the budget. So many professionals, so many installers tend to run away from this question. What is the available budget? Now, take for instance, if we have accessed Mr. Stevens' facility, and it happens that Mr. Steven has heavy energy need. That is to say, he has a freezer in that facility, he has a laptop, he has a microwave, he has 4 ACs, he has fans, he has a whole lot of other things. At the end of the day, we are seeing Mr. Steven to be needing a 20 kVA system. But we have assessed Mr. Steven and we have seen that, oh, Mr. Steven might not be um, uh, ready for this. So you can ask him, sir, what is the available budget for this project? So from his response, you will get to know if he's ready or not. Now, 2 things can happen. 1, his response can give you the green light that he's ready. 2, his response can also tell you that he is not ready. For the one that he is not ready, what do you do is the next line of action. That is why we are engineers, that's why we are solution providers. If Mr. Steven is not ready to afford what he is trying to power up at that point in time, what you can do is give him what he can afford, depending on his available budget. Let's take for instance, if the energy need of Mr. Stevens' facility is 20 kVA that is required to power it up, and then his available budget is about 5,000, we cannot be able to run that kind of installation or project. What we'll definitely do is to talk to Mr. Steven, let us give you something within the price range of 5,000 so that he can be able to at least have electricity in his facility at that point in time and then prepare for upgrade. So 3 important questions to ask. 1, the energy need. 2, the backup time. And 3, the available budget. Now, what are the importance of electrical load analysis? It ensures proper sizing of your system. It prevents overloading. It prevents fire hazards and improves safety and efficiency of your system. Now, when your system is not overloaded, you will not have fire hazards. When your system is sized properly, you will not have fire hazards. When it is now sized properly, no overloading, no fire hazards, the safety and efficiency of your system is improved. So that is the most important aspect of electrical load analysis. Alright. So I hope you guys are here. I hope you can hear me. Our client, Mr. Steven, are you still there? Alright, I hope you are enjoying the class too. Alright, thank you. I can see some hands up. Mr. Steven, Mr. Timothy, Mr. Messi, and the rest of you. I can see your hands up. Thank you for joining us. Thank you for paying attention. Thank you for obeying the simple rules and regulations. Mr. Matthew, I see you too. Now, the next thing we have on my screen is electrical load analysis table. Okay, this is a simple electrical load. Thank you, Mr. Anyway. I can see you all. So this is a simple electrical load analysis table. We have introduced electrical load analysis, and we said it is a series of calculations, a calculation of a series of calculations, or a process of evaluating the energy need of a facility. Now, we said the energy need will lead you to getting the information of the various appliances that are to be powered up using the solar system. Okay? Now, this table of load analysis, before you can be able to run a load analysis on a facility, before you can run a electrical load analysis on any facility, you are expected, it is mandatory that you take into consideration three standard parameters. Okay, you are expected to take into consideration three standard parameters before you can run electrical load analysis. One, the quantity of appliance. Two, the power consumed by an appliance. And three, the running time of an appliance. These are the parameters which helps you to run electrical load analysis. These are the parameters which helps you to size your facility and to know the energy need of your facility. Alright? So, the quantity of appliance typically tells you or gives you the information of how many appliances, how many of the same appliances does the client intend to power up using the solar system. That is what it tells you about. How many of the same appliance does the client intend to power up using the solar system? Okay, so let's take for instance again, Mr. Steven lives in a 4-bedroom apartment and he has 4 TVs. He has a TV in each of those rooms. So in your table of load analysis, it is expected for the quantity of appliance for TV, it is going to be 4. On my screen, there's an example cited. It says if a facility has 4 units of freezers and 2 units out of the 4 freezers are to be powered up using the solar system, therefore 2 is said to be the quantity of appliance during load analysis stage. You might also have it that Mr. Steven has 4 freezers in his facility, but then he wants to power up only 2 with solar system. Is it possible? Yes, it is very, very possible. However, when you are designing the solar system, you will only be taking into account or into consideration 2 freezers and not 4. 2 freezers and not 4. That is what you will be taking into account or into consideration when you are running your load analysis. I hope we are together. I hope it is very, very clear. Now, power consumed by the appliance. Power consumed by the appliance is the second parameter there. This power consumed by the appliance is a standard parameter that tells you the rated wattages of each and every appliance. Yes, it tells you the rated wattages of each and every appliance. That is what the power consumed by appliance is. Okay, so this rated wattages or power consumed by the appliance, where is it gotten? It is gotten from the nameplate of each and every appliance. The nameplate contains the name of the appliance, the model number, the serial number, the country of make, the wattage, the current, the voltage, even the frequency. On my screen, the picture you can see there is a typical nameplate of an LG TV. Alright, this is the time to know those who have really followed up with the explanation. This is an LG nameplate. Who can give us the power consumed by this LG TV from the nameplate? If you can see the nameplate clearly, please Let us know, Mr. Daddy Namtazi. Okay, go ahead, tell us.
195 watts.
195. Mr. Steven, do you agree with him? Can you see it clearly? You can zoom it in with your hand on your screen. You can zoom it in. Mr. Anyway, is it correct? Alright, so that is okay. Thank you, Mr. Matthew. Who is confused? Mr. Mali, are you confused? Okay, so the energy being consumed or the power
Yes.
consumption. Who is speaking? Talk to me. Okay, so the energy consumed by this appliance, this LG TV, is 195 watts, as Mr. Daddy has rightly told us. So on our table of load analysis, for the power consumed by this LG TV, it is going to be 195 watts. Alright, running time of an appliance. The running time of an appliance tells you or gives you the complete information on how long this appliance will be in use. So this simply means or simply tells you that the running time of an appliance only takes effect when it is turned on or when it is powered on or when it is in use. It runs in hours: 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. Remember, the higher your running time, the higher your cost of installation, and vice versa. Alright, now let us now get back to our electrical load analysis table and then do some calculation before we call it a day for today's training course. Like I said earlier, this is a table of load analysis. Alright, it's a table of load analysis, and like we have asked Mr. Steven, who is our client for tonight, his energy needs, and he has given us 5 appliances he wants to power up using the solar system. He has told us he wants to power up the DVD player, the light bulb, the ceiling fan, the refrigerator, and the blender. These are the 5 basic appliances he wants to power up using the solar system. Now, we are to run a load analysis in order for us to achieve what? The energy being consumed by these 5 appliances, which is the energy need of the facility. Now, we have the various data or information of these 5 appliances. For the DVD player, it is, as you can see on my screen, you can write. This is the only time you write for free. After now, it is only those who are fulfill your righteousness that can write. So, for the DVD player, the quantity is 3. The power consumed is 100 watts. The running time is 1 hour. The light bulb, the quantity is 1. The power consumed is 100 watts. The running time is 2 hours. For the ceiling fan, the quantity is 10. The power consumed is 10 watts. The running time is 24 hours. For the refrigerator, the quantity is 3. The power consumed is 10 watts. The running time is 4 hours. For the blender, the quantity is 1. The power consumed is 80 watts. The running time is 1 hour. That is the information that we have. So how then do we run a load analysis on these 5 appliances? It is very, very simple. So what we do is we use a very simple formula too. We use a very, very simple formula, and that formula tells you that energy consumed is equal to quantity of appliance multiplied by power consumed multiplied by the running time. Now the technique in this is that we are going to apply that formula for each and every of these 5 appliances. That is to say, we'll get the energy consumed by the DVD player, get the energy consumed by the light bulb, get the energy consumed by the ceiling fan, get the energy consumed by the refrigerator, get the energy consumed by the blender, and then we sum it up. That is to say, we add everything together to give us the total energy consumption. Let us get into it. For the DVD player, you have 3 multiplied by 100 by 1, which gives you 300 watt hour. For the light bulb, 1 multiplied by 100 by 2, which gives you 200 watt hour. For the ceiling fan, 10 multiplied by 10 by 24, which gives you 2400 watt hour. For the refrigerator, 3 multiplied by 10 by 4, which gives you 120 watt hour. For the blender, 1 multiplied by 80 by 1, which gives you 80 watt hour. So all together, summing everything up or adding everything up, you are going to be having 3100 watt hour, and that becomes the energy need of the facility. That becomes the energy need of the facility. So that is the magic we have been able to perform in Mr. Stevens' facility, and then we have gotten the energy need of the facility to be 3100 watt hour. And from here, we can now be able to go ahead to design for the various solar components. Alright, questions please. Mr. Anyway, I can see you are smiling. It's very easy, right?
I explanations are very clear.
Yeah. Alright, Mr. Steven, I hope we have been able to do a wonderful job in your facility.
I'm getting very well. Things are okay.
Alright, okay. So, if you have a question or questions, you can talk to me right now, talk to us right now. Speak from a quiet background, please. Use the chat box to send in your messages as text. Let's hear from you all. Okay, Mr. Daddy, your hand is up. Talk to us, please.
Just a question. The total number 3,100 watt hours.
Yes, sir.
This is this the energy need for a day?
Yes, that's the energy need for a day. Yes.
Thank you so much.
Not actually for a day. This is the energy that will be consumed per hour, because if you look at it, is hour, not day. Okay, so Mr. Joe is asking on the chat box. You guys are not telling us where you are from. Okay, so Mr. Joe is asking. Okay, so Mr. Joe is saying, using that example, you can tell us the solar panels, inverter size, and battery needed. Oh, Mr. Joe, sorry, we cannot give you that information because